All right. So next we're going to learn about BGP innovations for operational challenges. Take it away.
Hi, everyone. I am Joop Snijders. I volunteer for PeeringDB, OpenBSD, NANOG, and in my spare time I work for NTT. And today I would like to share with you an update on what has happened in the last 12 months in the IETF world. For a number of years there was a bit of stagnation from the operator perspective. There was a bunch of features that we would like to have but didn't get for some reason. And a lot of those gaps have been closed in the last 12 months, and therefore I would like to get everybody up to speed on that. So we refer to this as the battle of operations. Not all of the RFCs were created with the usual friendly atmosphere that is at the IETF. Some of this was done with pitchforks and flamethrowers. But in the end, we came out on top, and that's the good news. A bit of background on how BGP development actually works. There is the IETF, many of you have heard of this, the Internet Engineering Task Force. And within that standards body, there are many working groups. And each working group is responsible for a problem space or a protocol specification. And in the case of BGP, it's actually split up over two working groups. There is IDR, which owns the protocol itself. It stands for Interdomain Routing. And then there is GROW, which are the users of the protocol. And there's an interesting feedback loop between protocol designers and users of the protocol. And I think this is a very healthy situation, and other protocols should perhaps copy the approach, because it's always good to have a sort of advisory board on what direction the protocol is taking. So in the last 12 months, several RFCs have been published, and some of them are still in flight as internet drafts. That's a status before they become official, so to speak. And in this presentation, we'll go over 5 aspects of that. Should you be interested in participating in this type of work, I strongly recommend that. The only reason we got this far is because of operator involvement. Hundreds of people showed up and voiced their concerns and or called their account managers. This was a group effort, and that works if you involve yourself with the standards body. So at a very minimum, I would recommend to join the GROW working group, because that's where we as network operators hang out and get to chime in on, with our opinions. So the agenda for today. This is a bit of a weird presentation, because it's not one gigantic presentation on a singular topic. It secretly is 5 lightning talks. And with some of the topics you've already heard me at a previous NANOG or perhaps a RITE meeting. Other topics may be new to you. So if you doze off, don't doze off for longer than 10 minutes, because then I'll be on the next topic. It also means that feel free to interrupt me at any time. If you have a question, don't wait till the end, because everybody will have forgotten what we were talking about. Just come to the mic and we'll go through questions as we cover the topics. So the agenda starts with some security innovations, safety things we did in the BGP protocol, management of your network, coordination between organizations facilitated by BGP, and then finally some performance improvements that will reduce packet loss during certain events in your network. All right, the first one. The concept of black holing may be familiar to many of you, and it remains to be a crucial tool in today's operations. All too often, the economics don't work out to keep a victim of a DDoS attack online at all cost, and you have to sometimes make the hard and difficult choice of sacrificing one IP address's reachability in favor of the rest of your customers. And the way a DDoS attack works is that you are overwhelmed, you're flooded with traffic that you did not ask for, did not request. It comes into your edge, and the edge congests, or the applications congest. So to improve this, the operational handling of this type of problem, many years ago, black holing was described as a good mechanism where you can signal to adjacent networks, I don't want to receive traffic for this destination IP address, stop sending me traffic. And by doing that, you can alleviate the pressure on your edge network. But every provider had different BGP communities to accomplish this. And this means that for every partner that you're interacting with, you have to coordinate with them what is the BGP community that is used to signal this. No longer. So we now have an RFC that describes a standardized black hole community. This black hole community is 655.35:666. This is a community that has been assigned by IANA for the purpose of signaling to adjacent networks, I don't want to receive traffic for the destination described in this BGP update. You put that community on the announcement after you've detected that an attack is ongoing, and when the attack subsides, you remove the community and you return to normal operations. Another advantage of this welcome community, when we started this work, there was no outlook on a community solution for 32-bit ASNs. So 32-bit ISPs using 32-bit ASNs had trouble assigning communities for this function. And that's why the well-known 16-bit community is useful, particularly in that context. There are some considerations when it comes to this community. It is up to you to either honor or ignore the meaning of this community. And usually this is driven by the commercial relation you have with the adjacent network. For instance, if the adjacent network is a bilateral peering partner, you may not feel inclined to facilitate the partner with this feature. However, if it's a customer-vendor relation, you may want to consider offering your customer the black holing mechanism. So nothing in this RFC forces you to implement black holing. It's just if you use black holing, you may also use this well-known community. You must agree between the two networks to use black holing. And if you're not offering black holing, you should strip the community on site. So on sessions where NTT is not offering black holing, we will strip this community to reduce the impact it may have further down the line. If you do black holing, always add a no export community. It rarely is helpful if such routes propagate any further than the direct adjacent networks. And if the adjacent network also wants to do request black holing from its adjacent networks, they should regenerate the route and insert it themselves into the adjacent network. So make sure that you limit the scope of propagation by using no export in combination with the well-known black hole community. And another safety trick, so to speak, is to make sure that you only accept this feature on the most specific routes. Generally speaking, /32s or /128s do not propagate very far on the internet. Most people have boundary filters, which only allow up to, say, /24. So by requesting people to use the most specific route, if they are black holing, we further reduce the chances of it propagating to places it shouldn't. We have a question.
Patrick Elmore, Markley Group. I'm interrupting you as you requested. Can I make a suggestion to additional bullet point on your usage guidelines? You should make sure that the person advertising, the network advertising the black hole route actually owns that 32.128 so they don't black hole somebody else?
That is an excellent point. After this RFC was published, we've seen various deployments. We've seen deployments which aligned with the text as specified in the RFC, where we explicitly state, make sure the network is authorized to announce this route to you. But we've seen some deployments where this advice unfortunately was ignored. Patrick, thank you for reminding us of this. Make sure you base the filters off IRR or RPKI or a combination, or somehow a mechanism where you explicitly agree with the adjacent network that they have authorization to insert black holes. Because it'd be a real shame if you start black holing your competitors. Oh, actually, we had a whole dedicated slide. I'm sorry, I cannot see the next slide, so I have to go from memory. Another aspect is the black hole community in itself, it's just a number. There is no BGP implementation out there that automatically starts black holing if they see this community. You have to explicitly configure your border routers to set the next hop to something that goes down the sink. So there is no magic here, it's just a mutually agreed number that represents a certain feature that we all understand as black holing. All right, that brings us to a slightly different topic. Well, before I continue, there's another question.
Hey, Job. This is Ashu, Juniper Networks. I was just curious. Instead of using this black hole community, there has been another standard called FlowSpec, where you can specify various more filtering actions like limit the traffic rate or sample. And you don't have this validation problem there because the standard itself makes sure that the person who is telling you about rejecting a particular rejecting traffic for a particular destination gets validated via the unicast routes that have come in.
Thank you for that contribution. I view FlowSpec and black holing not as mutually exclusive. They are different products in different contexts. The validation aspect with FlowSpec happens at a different stage because I still need to filter out what I want to accept from an adjacent network or not. So I need to build the authorized whitelist anyway. You're right that there are some additional mechanisms in place to ensure that it affects a particular cone through the network. So it may alleviate one type of problem a little bit, but it may introduce other types of problems as well, because filtering the actions on FlowSpec announcements is not always straightforward on all implementations. So, and another aspect is FlowSpec. This trick, black holing, we can implement it on the oldest of iOS boxes. So it's a really low common denominator. It's a very basic tool. It is a crude tool because we're throwing away all traffic, but it may be better than having no tool. And from that perspective, I would like to popularize the idea that black holing is a basic feature. But if you can do more, or if you can have more involved participation with your customers and partners, sure, FlowSpec is absolutely on the table as one of the mechanisms.
Thank you.
Next topic, safety, RFC 8212. This represents a route leak. And we got tired of those. There were a number of implementations out there that under certain circumstances would expose default behavior that was less optimal for, say, everyone. And we set out to try and define behavior that is more aligned with internet operations rather than throwing a dice and picking that as a default. So what we do in this RFC is we define that on an eBGP session, if no policy is associated with the particular session, you should not accept routes, you should not announce routes. And this default ensures that if you're halfway through your configuration or there are unintended consequences of the way your configuration management system pushed something out, or there could be all kinds of reasons why you have no policy on an eBGP session, while in reality you need to have some kind of safety mechanism there. This RFC defined for the first time what the default behavior should be if there is no policy associated. And this was a very tricky one because it goes counter to years of operational experience that we have, in the sense that we are used to certain behavior, maybe not happy with it, and now we have a definition of what the desired default behavior is. But that road is not trivial because there are a lot of BGP speakers out there that adhere to more promiscuous standards. So opponents argued we can never change defaults. Fortunately, we know this is not true. Defaults are changed all the time. It's just a matter of energy and cost expenditure. So some defaults are hard to change, but we can never not change them. People argue that changing default behavior may break people's operations because they are relying on the behavior that was unspecified. But we also see that the lack of a proper default behavior, which is a safety mechanism where we don't announce or don't accept routes, lack of that behavior also breaks things. So it's a bit of a balanced thing that had to be figured out what is more important. And I would argue that the default-free zone is something all of us share, and incidents in the default-free zone not only affect your own operations, but you can negatively affect the networks around you. And a shared resource, similar to the environment, should take priority. So I'm going to spend some time on being sure that you memorize this piece, because some opponents argued that customers do not read release notes, and they do not read the NANOG mailing list, and they do not attend NANOGs. So that put the onus on us to make sure that you have this message in mind and that you are informed of this new aspect of BGP. So let's look at an old situation where I will not name out a particular vendor. But if you look at this configuration, what will happen? This is what is technically called, it will cause a lateral AS to AS to AS leak. Because the cloud image in the middle that had those 5 lines of configuration, because that's the minimum amount of lines needed to get BGP sessions up and running, how it interprets that piece of configuration is that it will accept everything from AS 64555 in the upper left corner, admit that to its local RIP, and it will also advertise everything because it was not configured to do otherwise. And this type of situation happens all too often, unfortunately, and it negatively affects all 3 of the ASNs in this image. All 3 of them will be routing through links that are too small or increase the latency. This happens daily. So what RFC 8212 does, it adds airbags to this situation. The specification says if there is no policy associated with the neighbor, do not announce or accept routes. And because this must be built into the router, the parallel with airbags is appropriate because this is a built-in safety mechanism to protect you from harm. So post RFC status is that implicitly, secretly, under the hood, there is a route map application if nothing else was specified. If you explicitly specify accept all routes or announce all routes, that's good, because you made a conscious choice, I want to announce everything. And you'll make it easy for your colleagues or contractors, because if they read the running configuration, they see, oh, here we explicitly intended to announce all routes. Unfortunately, after publication of an RFC, there is no immediate update of all software worldwide. So there's a bit of a way to go. Another advantage of this specification is that it unifies the behavior between platforms. We've seen variants where, for instance, the platform will not accept routes, but will announce everything. We've seen variants where it will only announce routes that originate within the AS, but nothing else, or it will announce everything, but not accept everything. It's a bit of a mess, so to speak. And I think we as operators will benefit from unified behavior across multiple vendors. And last but not least, as I mentioned before, the default free zone is a shared resource, and this type of approach helps protect that. There's a small list of BGP implementations that are widely used, but are unfortunately no longer compliant with the core BGP specification. And we need to do some work. We need to ask our vendors for this specific feature. We need to demand that the default behavior should be safe behavior rather than opportunistic behavior. We're keeping track on the GitHub page of the developments that we see in this space. This will take a number of years, I imagine, but without your help, it will be very hard to get this RFC as production code.
Matt Petak, Yahoo, quick question. You're saying this is to protect the default free zone, which I totally respect. Is this going to have a knob that's turn-onable, offable for labs and other environments that aren't touching the default free zone, or is this just across the board, everywhere, doesn't matter where in the network it is, we have to protect the default free zone even if you never touch it?
Hi, Jared Motch from NTT. So Matt, wow, I don't know. I've got 15 years or 17 years. Hi, Jared Motch from Akamai. It takes me a little while to remember this. Now I can be sufficiently embarrassed for the rest of the meeting. So Matt, this was a common refrain that came up, in some of the discussions. And for example, in iOS XR, you can simply emulate the iOS Classic configuration mode by configuring something called, I think it was like eBGP unsafe default or something like that, where it explicitly says, hey, I'm doing this unsafe thing for the lab. And with pretty much all the vendors moving to like a ZTP type environment or capabilities, it would totally be easy and feasible for you to ZTP that into your lab environment, because as we all know, we automate our labs and nobody uses VI or notepad.exe as your SDN controller. So, as part of this, my recommendation is that people, look at this as something, because you really, we no longer configure open relays, and IP-directed broadcast that was used in Smurf attacks was the default for a very long time. And this type of a change, I think, is long overdue to secure the routing ecosystem, to go and say, please behave in this safe way, because the lack of an atomic-based configuration model by some of the vendors goes and, they're listed, really, it harms all of us by having it do this thing without you intending it to do it. And it's very dangerous, and it's something I'm very concerned about, myself personally.
Like with directed broadcasts, you notice there was a explicit config knob associated with that could be flipped.
So to that point, the RFC does mention, so the RFC is structured as following. It says you must not accept or announce prefixes if this is the situation, but vendors may provide a knob to turn this off. So one is a requirement, and the other one is an optional suggestion to the vendors, like, well, of course you can provide a single button to turn this off, but at least that button will be explicitly visible in the running config. And that, to me, is a big benefit, because if I'm grabbing through configs, I can see which ones are operating in secure or insecure mode. And further to that point, if you start shipping, if you're a vendor and you start shipping boxes that have a dip switch on the front that allows you to do insecure mode, great, that's compliant with this RFC. If we make it into a DHCP boot option where it says boot with insecure default mode, that's fine. But the default, if I just unpack a box and put it into the network, the default should be safe. So please reach out to your vendors on this one. More questions?
Julian Goodwin, Google. Did you also look at encouraging vendors to not auto-accept when a route falls through, particularly with, say, chained policies, Junos style? You can end up with an error where you miss a policy off the end and suddenly announce half a global table.
That's a good question. We briefly thought about it to give guidance on what a policy construct should look like and whether a default permit or a default deny should be done. But as we went along, this simple thing, well, simple in words but not in execution, was already quite complicated. And not all the vendors share the same abstract concepts of policies or chains or a language construct. So I would love to see a fill closed situation where you don't have a fall through that is open and you start accepting, but rather something else. But that is really hard to standardize on.
Thank you.
But to your point, I would recommend that from this day onwards, you assume that the routers behave in a certain way and that you make sure that you're never relying on implicit behavior of the box. In any context, regardless of this particular RFC, but relying on undocumented or poorly documented or changeable defaults, where they could change from release to release, may not be the right thing to do. And explicit configuration will facilitate your operations specifically in this regard. So if you notice that you have eBGP sessions in your network and there's no policy associated with them, an example could be where you're feeding a looking glass. For instance, the route views or RIPE RIS, you may have taken a shortcut and just not configured policy and it will barf out everything it knows. Look for those instances in your network and amend them so that you explicitly tell it to announce everything to such looking glasses. Check release notes, read them, read the documentation, because somewhere in the future, your vendor may start agreeing with the RFC, and if you're not looking out for that particular topic, and you're not testing, and you're upgrading all your routers at the same time without canary, then you may be in for an unpleasant surprise. But of course, many of us at least check if the software boots, so I'm sure there will be no trouble in that regard.
It's probably not covered by the RC, which, by the way, I supported. Dunsmith CenturyLink. Do we get some kind of a screen that says default behavior is now don't advertise and don't accept? I hate implicit rules. You mentioned the word implicit. I hate implicit rules. I want to see it in the config someplace. So I want the default to be do not accept star, do not send star. I'd like to see that in the configuration. That's actually for the vendors out there, Cisco, Juniper, et cetera.
Yeah, if a vendor is in a position to make implicit behavior explicitly visible, that's great. Not all vendors have this. I mean, some of the BGP implementations run off a text file. With others, it's sort of a shell into a database construct where that may be easier. But talk to your vendors, and if you tell them, I want this behavior, and I also have some suggestions on how I want things to look, I think they would appreciate that. Management, next topic, next lightning talk. And we're perfectly on time, so this is going well. Many of you have heard about large communities, but since we have a ton of newcomers this NANOG, it is critical to make sure that everybody receives this information. A bit of background. About 10 years ago, 32-bit ASNs were specified because we knew that we'd run out of 16-bit ASNs at some point. And if we look at the current growth trajectory of the default free zone, there are currently 55,000-ish ASNs in the default free zone. Theoretically, you can have around 65,000 ASNs if you use 16-bit integers. So it is clear that something is too small somewhere. And this was identified, people start working on it, and now we have 4-byte ASNs. The RARs started allocating networks, numbers from this extended space, from the 32-bit space in 2007. And with most RARs, there is no difference between 16-bit and 32-bit ASNs. However, in the 32-bit ASN RFC, it was specified, oh, folks, keep in mind there will be a problem with BGP communities. And I think people felt proud that they had explicitly specified that in the RFC as there was still a to-do item. Unfortunately, that to-do item was not successfully followed up on in the subsequent 10 years, and this led to a sort of emergency situation where we saw the pool of 16-bit ASNs depleting, uptake of 32-bit ASNs, and no universal BGP community framework to coordinate within your own network or between networks. So something larger was needed, and the picture on the screen kind of demonstrates the design philosophy behind large communities. We really wanted it to look, smell, taste, feel like the regular classic communities, but just larger. That's it. And all the characteristics that we are used to and love in normal communities should be replicated to large communities. And that was resolved by RFC 8092, called the BGP Large Community Attributes. This was done in a very high-paced philosophy. The first internet draft was published in September 2016, and in February 2017, it was an official RFC. And that is incredible for IETF work. Usually, RFCs take 2 or 3 years to mature, and in this instance, we did it in 6 or 7 months. And I'm very grateful for that because there was urgency. We were running out of space in some areas, and it takes years to deploy technology like this. If we look at NTT's network, it may take up to 12 months before a given edge router receives a software refresh. And it does take some of the vendors between 12 and 18 months to develop the software that I was going to load in that instance. And then if you tack that on the 2 to 3 years in IETF, you're looking at 5-year time spans, and that would have run well into the depletion of 16-bit ASNs. So the fact that many people recognized this and stood up and helped progress this through the standards body is appreciated. And this includes the participation from the vendors that are also fast-tracking this particular feature. We kind of think that 2018 will be the year of large communities, and the reason is that then most of the well-known vendors will have implemented support and put out public releases of software that can use large communities. There's a ton of resources available at largebgpcommunities.net. That's where we track presentations, software examples, implementation status, anything related to this feature. There's also a companion document called RFC 8195. This companion document to the official specification provides you with numerous examples of how you could use large communities in your network. And you'll find that a lot of things are much simpler now that we have more number space compared to what we had with classic communities. This is a long list. Arista has been planning this. Brocade even is planning to support this. iOS XE is slated for June 2018. XR is probably coming later this year. Junos already is shipping software with large community support. All of the open source projects that talk BGP have been patched by volunteers to support large communities. So we're looking, the outlook is extremely positive, because with a thing like communities, you want it to interrupt between networks. That's where we use it. It is a demarcation point, the eBGP sessions, where we signal to other networks, this is what I want. I want different traffic engineering. I want prepending. So it is really important that all vendors support this. Otherwise, we cannot deliver our products. But we're looking really good on that. Not only the BGP implementations themselves needed patching, but there's a whole ecosystem around BGP that also needed to be upgraded. We took care of this. And you can think of things like TCP dump or T-Shark or PMACCT or MRT parse or Wireshark. All these things that we use to either analyze traffic flowing through our network or debug BGP packets flowing through our networks had to be patched, and that's been done. Any questions on large communities specifically? Everybody good to go? The next one is the topic of coordination between administrative entities, otherwise known as I have my network, you have your network, and sometimes we need to coordinate or cooperate on how we run things. Communication in this problem space can be really challenging. We all know the example where somebody emails to the Internet Exchange technical mailing list, I will do maintenance, and then 2 other people reply, what's the circuit ID? 5 mill robots start opening tickets on everybody's behalf, and and you're like, but I don't even peer with you. This is annoying, and it's very hard to optimize on that, because what other option do you have other than to broadcast if you cannot narrowcast? We tried different methods of communication. Here I'm using a bunch of /24s and flapping them so that in RIPE's BGP analysis tool, an image was instantiated. But this took 5 months to generate, and it's not a viable way to communicate. Therefore, we now have the BGP administrative shutdown communication. The coordination problem is that when I tear down a BGP session, you, as the person on the other side of the session, may not know why I am tearing down the session. Is it because I'm doing maintenance? Is it because you didn't pay the bills? Is there some other reason? Is there a network problem? This is hard to figure out from the syslog message itself. So the solution to this is that you can now embed a small message in the BGP cease notification BGP message. It's kind of confusing. Everything in BGP is called message, and depending on the context, it may be the outer packet or something within it. But the point is, when I tear down a session, I can now associate text with the event that it was being torn down. And that information is logged in your syslog. Messages can be up to 128 bytes. UTF-8 is supported, so you can send emojis over BGP now. We did it. But you're laughing. The reality of it is that there are more characters out there than just 7-bit clean ASCII. A large portion of this world does not speak English, and they use different character sets to communicate with each other. So from that perspective, that we want something to operate on a global scale for everyone on this planet, UTF-8 is the only valid option in a context like this. And you'll see this more and more in ITF, where if there's text involved, UTF-8 is mandatory. Usage guidelines. You can send an administrative shutdown or an administrative reset. Those are two BGP events that you're all familiar with. And with these, you can, for instance, include a reference to a ticket number or a phone number or an email address or just a short message, I'm going away for 30 minutes, see you later. On the receiving side, you should try and capture these syslog messages into your NMS if you have a place where you aggregate things. And perhaps you can do lookups for the ticket IDs. And I see all too often that NTT initiates maintenance, we shut down BGP sessions, and our customer calls us saying, hey, why is the BGP session down? And we're like, well, we sent you the notification 2 or 3 weeks ago. And they're like, oh, yeah, you're right, I'm sorry. And if we have the reference ticket or ticket ID in that syslog message, we can encourage people to search in their mailbox or other central tracking system, and they'll be like, this is the maintenance as announced 1 or 2 weeks ago. I'm gonna ignore this for a while, but if it's still down after 5 hours or whatever time period, then I'll start calling the NOC. And I really hope that the shutdown communication mechanism will greatly reduce the chatter that we have between all of our NOCs. So this is an example from OpenBGPD on OpenBSD. There's BGP control, which is the binary to instruct the daemon to do things. You type in BGP CTL neighbor IP address down. That was all standard. And now as an additional feature, we can add a sentence to that command that says, we're upgrading, be right back. On the receiving side, in syslog, you see that the session goes down and what the reason is the session went down. And these are tightly coupled to each other, so that makes it easier for parsing. There are a number of implementations on their way. In the open source world, we're slightly ahead of the traditional vendors, but I've heard interest being expressed from the big ones that they would also want to implement this. So I don't have a time frame, but this is one of those RFCs where you should really ask your account team, I want that feature, please implement it. If all of us ask, it will be done in no time. If there's only a few of us asking, even if we're big companies, it will not get the priority I would like it to have.
Quick question, Matt Petak, Yahoo. So you're sending 8-bit data across from another network to yours, piping that into syslog. It's going through syslog. Have you done any interoperability to make sure that you can't pass random binary strings into your syslog daemon this way?
Not really.
So we could be opening up an interesting security hole here, is what you're saying.
No, I don't think so. There are many libraries out there, even for crazy languages like C, that will help you sanitize unquantified data. There's, for instance, VIS, which will force a octal representation of strange things. And so a lot of these problems have been tackled in syslog itself. And since we're just passing on a set of bytes to the syslog existing infrastructure, that problem should be mitigated already because we have been doing syslog for a number of years. Another trick is the shutdown communication is not null terminated. There's an explicit length field. So you, as an implementer, you know exactly what you're getting. And if it's garbage, you just ignore it. And if all the things line up, you pass it on to your syslog infrastructure.
Okay, the explicit length does help, thank you.
Now on a slightly different topic called performance, there's 2 subtopics. One is graceful shutdown and the other is called BGP session calling. And I now realize after 12 months of IETF work that we should not perhaps call everything shutdown because it's confusing But this is what we have to work with. BGP session calling is a BCP, a best current practice document. And this means that by specifying it as a BCP, you can include references in your RFPs or in your peering agreements where you tell networks, this is a operational procedure and I would like you to follow it. Or, even better, you can tell your customers, I am compliant with this specific described operational procedure. And within the BCP document, there's two types of maintenance. There is maintenance that I, as the administrator of a BGP speaker, initiate. That's called voluntary shutdown. Or there is maintenance that the internet exchange point or the layer 2 provider between me and other people is undertaking. If you do voluntary shutdown, there's a number of things you can do. You can first drain the traffic. When you've drained the traffic, you can use the BGP shutdown communication to signal why you are shutting down. You can use graceful BGP session shutdown to make the draining of the traffic smoother. That's all nice, and many of us are properly shutting down sessions before yanking cables. But a more challenging one is the one in the case of an internet exchange. There is no signaling mechanism from a complex switched layer 2 fabric to the higher layer that is the BGP session. But as with engineering, we often see a bit of duct tape is good enough. Some smart folks figured out, hey, why don't we disrupt the BGP sessions crossing a particular switched fabric, and that will cause rerouting, which is exactly what we want because we want to drain traffic. And that is called involuntary shutdown. Someone else is disrupting your BGP session to protect you from the negative effects of the maintenance they are planning. To that point, with graceful shutdown, if you shut down a BGP session, you risk a little bit of black holing. And this can happen because BGP routers tell each other their best path, and up until that point, if they send a withdrawal, then other BGP speakers may do best path calculation, and then you get back a best path, and that propagates to the edge router that initially received the withdrawal. And in that small time period, there may be no route to the destination. So if we walk through this with the image, on the lower bottom, you see a yellow circle, and that represents my autonomous system number, and it's just one router. The upper three blue balls are your autonomous system number, and in the middle, you have a route reflector. I have a session with both your border routers, and if I want to shut down one of those two sessions, I type in shutdown, and this will cause the border router on your side to generate a withdrawal message internally and redistribute that to the iBGP sessions. From that moment on, it no longer has a route for the prefixes I was announcing over that session. The withdrawal reaches the route reflector realizes it has an alternative path, and it sends back, this is the new best path. Up until that point, there was no route on that one edge router, so it was black holing traffic. So that is not ideal. I'm assuming that if we have BGP sessions with each other, it is because we want to exchange traffic. It's not because we want to drop traffic. And there's fortunately a cute little trick called graceful shutdown that can mitigate this particular failure scenario. What happens with graceful shutdown is that before I actually terminate the BGP session, I tag all my announcements with a well-known community called the Graceful Shutdown community. And this is an indicator to your border routers that the path they received will be going away soon. Of course, routers, many of them have no concept of time, but what happens is when they see that well-known community, they can lower the local preference and signal to the rest of the network, apparently something is going to happen to this prefix, so it's undesirable. But even when it's undesirable and it has local preference 0 attached as attribute, it is still in the FIP and you're still forwarding packets, so there is no outage. The BGP update reaches the route reflector with that well-known community to signal it's going to shut down and the lower local preference, and the route reflector does its best path selection and will signal back a path with the normal local preference, the alternative path. The moment that alternative path is offered to the edge router where I'm going to shut down the BGP session, you can hitlessly install that prefix in your FIP, you change the pointer out, you start forwarding packets in that direction now, and there is no outage for anybody involved. Then you actually shut down the BGP session and you do your maintenance. The well-known community is 65535:0, and I would like to recommend everybody to start looking into this mechanism to make maintenance a bit more smooth. The guidelines, the nice thing about this approach is that we can implement it on every platform on the planet. All BGP speakers, or at least everything that was produced in the last 10 years or so, support BGP communities. They support matching on a BGP community and then setting attributes to specific values. So what it boils down to is, if you see a prefix with that well-known community over an eBGP session, lower the local preference to 0. That's it. That way you support receiving graceful shutdown. On the sending side of things, so for the person that is initiating the maintenance and wants to guide traffic away, what you should do is you should change your routing policy to add that well-known community to all announcements. You tag the announcements you receive with a low local preference, so you start draining in both directions. You wait a period of time, it could be 5, it could be 10 minutes, it depends a little bit on your hardware, and then you shut down the session and you can normalize the situation. There is no guidance on how long you have to wait. I recommend that you just look at the traffic, and when it reaches a certain low point, then you're like, okay, I'm calling it, let's do it. Because an MX80 will converge slower than, say, a nice MX 2020. And with this mechanism, the cool thing is that it doesn't really matter how fast they are converging, because all BGP speaking elements are allowed a chance to converge without packet loss. What this looks like in configuration examples, on the upper left side, there's iOS XR. There is a policy that you associate with eBGP sessions, and you just simply match, if this community is present, lower local preference to 0. On the Arista, Brocade, iOS, Quagga, FRR side, you can use route maps, and in route maps, matching on a community and setting a local preference is very easy. For Nokia, we have an example as well. So you can see we can implement this on virtually every platform that we are using to run the internet today. So to summarize, if you see the graceful shutdown signal, that BGP community, it is basically a broadcast of saying this path should be undesirable. It's going away. We're going to yank the cable. So stop using this path. And this will initiate an advanced sequence of events. There's a ton of science why this works the way it works. But the end result is that you can seamlessly switch to an alternative path without disrupting the traffic between your two ASNs. There's a number of networks that support this already today. NTT, GTT, GitHub, Nordinet, Coloclu, MCO, BIT. And I think this group of networks that support receiving shutdown communication, graceful shutdown community will increase as we go. Ask your transit providers, ask your peering partners to implement those 2 lines of configuration.
Dumb question. Would it be good to put a no export or no advertise along with that?
It's not a dumb question. Well, it's a good question because there is a group, there's the school of thought that no export is a way of gracefully draining the traffic. But the strange thing that happens with no export is that the withdrawal doesn't happen on the border between you and me, it happens on the border further away. And I have even less visibility into that. So a customer of NTT may say, stop exporting this route, and that generates withdrawals on all eBGP sessions towards the rest of the world. And those withdrawals are what is hurting, because the withdrawal will need to propagate up to a speaker that has an alternative path, then the alternative path has to propagate back to the node that received the withdrawal, and in that time period, you may be blackholing traffic. So no export is not beneficial in this context.
Thank you.
I think the question was about the security. Rafał Szerecki, Juniper Networks, and to prevent propagation of the GSHAT across the end AS border. Just saying to your neighbor and don't propagate this further. But it's kind of done automatically because local preference 0 means that it's not selected if there is any better path. So it's contained locally anyway.
And to that contribution, I think it is beneficial if the community propagates across multiple ASNs, because my ASN may not have a better path, but my peer's ASN may have a better path. And the moment they realize that the path through NTT is not desirable anymore, they may tell NTT a better path. And up until that point, we may not have had that alternative path, but because of allowing this to propagate across multiple ASNs, we increase the chances of finding an alternative path. From the security perspective, all this is just a standard traffic engineering BGP community that lowers the local preference. Almost every transit provider already offers this today. The only difference is that I also ask peering partners, which you would normally not grant any traffic engineering features, to allow me to do graceful maintenance. And that goes back to the point where if we're having a BGP session with each other, I think it's because we want to forward traffic and not black hole it. So please allow me to use graceful shutdown community on your network as well.
Jacob Heights from Cisco. So it's either you propagate the withdrawal or you propagate the GSHAT. GSHAT's better to propagate.
Yes. Withdrawal's bad, GSHAT's good.
Withdrawal go after that, right? Anyway.
Where are we now? So the BGP session calling where we do involuntary maintenance has a slightly different mode of operation. It's less graceful, but it is what it is with the equipment and signaling mechanisms that we have today. But imagine there is a layer 2 switch, and you and I are both connected to the layer 2 switch. And the layer 2 switch is actually multiple layer 2 switches connected to each other, forming a switched fabric. If the link goes down on my side because that switch is being upgraded, you will not see a link down event on your side because you're plugged into a different switch and that port is going to remain up. We'll be waiting for a BGP timeout to happen, which can be up to, say, 180 seconds. And during those 180 seconds, your router is sending traffic across a layer 2 fabric that is blackholing it. One way to mitigate this would be that everybody reads all the maintenance announcements from their internet exchange points and interprets them correctly. But as we've come to learn, this is not realistic. There's too much communication already. It is very hard to communicate to all affected parties when something is going to happen and also have them act on that notification. So a layer 2 fabric operator can be more proactive in that regard. And a trick that was developed on LoNAP, an internet exchange in London, is called culling, where you insert a combined layer 2, layer 3, layer 4 ACL in the switch platform that only affects BGP traffic that originates from the peering LAN prefix, is on port 179, and is destined for peering for IPs within the peering LAN prefix. If you kill that traffic, after 180 seconds, the BGP sessions all timed out, but meanwhile, normal traffic, our VoIP, our gaming, our YouTube, the cats, that is still forwarding. So from the router's perspective, we see the neighbor disappearing and timing out, but in reality, the data plane is still doing a useful job for all of us. And this is a really cheap trick to ensure that maintenance on internet exchange points is less disruptive than it needs to be. Of course, there's also other approaches. Some internet exchanges have photonic switches, and they, before doing maintenance, flip you over to a backup switch. I'm sure that in the wild there are different ways of mitigating this type of problem, but in a general use case where an internet exchange is across multiple layer 2 switches, this is a really good trick to prevent blackholing your internet exchange participants' traffic. So when you go shopping around for internet exchanges, make sure to ask them whether they support BGP session calling, and if they don't, ask them why not. Be sure, as an internet exchange operator, to only affect traffic from and to the peering LAN prefix on TCP port 179. Any other traffic is not yours to touch. So if you do a blanket drop of port 179, you may also be killing BGP sessions that are not related to the internet exchange itself, but are, for instance, spam blacklist distribution lists or BGP looking glass sessions or whatnot. So it's really important that you confine this action to something that is actually part of your infrastructure. Make sure that you apply this for both V4 and V6. You can observe after you've applied the ACL whether traffic is actually draining. If it's not draining, double check your config. And if you see it draining, wait until you see it hit a certain low point. There is no predicting how long that takes, but in the case of LoNAP, we see between 5 and 10 minutes. But it, of course, depends on the hardware capabilities of all the internet exchange participants. When you're done with your maintenance, remove the ACL, the sessions come back up, and all packets were saved. I have 3 more slides, but no time, so I'm going to go quickly through this and hope the PC doesn't drag me off the stage. Shipping now. Graceful shutdown. You can implement this on your network today. You don't need to wait for your vendor. Just change your routing policies. Allow all eBGP peers to signal you that they are going to shut down. That one is easy. Session calling, because we're recycling existing tools on modern devices, you can implement that procedure easily if you're running modern equipment. The black hole community is also shipping today because it's just a well-known community. What's partially available is large BGP communities. There, we still need to keep encouraging BGP vendors to implement this. The shutdown communication should also be on your list of things to ask from your vendors. And the eBGP secure defaults, RFC 8212, is also only partially available today. So the call to action is ask your vendors for these 3 RFCs. Vote with your wallet. Uh-oh. But the more people ask, the easier this becomes. And vendors listen to either rich customers or a lot of tiny ones. And we, all of us together, can be that second group to make sure that we have good BGP operational tools. That's it for today. If you have questions, I'm here till Thursday. See you later.